Hello and welcome, Midnight Coders. In today's video, we are diving deep into the world of JWT, or JSON Web Token, commonly pronounced as JWT. So, I'm going to explain what these are, how they work, as well as how I implemented it inside of the Midnight Technician. So, if you've ever dabbled with JWTs before, leave a comment about some of the challenges that you had to overcome, and we will see if I happen to explain those in this video. So, make sure that you've got a full cup of coffee, and let's dive on in. So, what is a JWT? What does it look like? A JWT is a way of stateless authentication, which is usually signed by the server using either HMAC or RSA. HMAC is a hash-based message authentication code, which is a cryptographic technique used to ensure both the data's integrity as well as its authenticity. It combines a cryptographic hash function, typically SHA-256, with a secret key. RSA, on the other hand, operates on two keys, a public for encryption and a private for decryption. As you can see in the image, a JWT is broken down into three parts. Ours is represented by green, white, and blue. The green is the header. There is then a period. The next section, which is the payload, a period, and then a final section, which is the blue section, the signature. So inside of the header, typically it usually says something like the type of token it is, which is usually a JWT. So I felt it was kind of redundant. So here we're just describing the algorithm, which is HS256, which in our case is the HMAC with SHA-256 encryption. The payload, you'll see, has the issued, so who issued it, and in our case, it was the Midnight Technician website. Who the audience is, which in our case is the users. Subject, who is this, who belongs to this ticket, or who owns this token. In our case, it is the ID or the email of the specific user. Then we have an issued at timestamp, an expiration timestamp, followed by the roles that are associated with this user. All right, so let's imagine that you go to a movie theater, and at the entrance, you buy a ticket. This ticket has printed information such as the movie name, seat number, and the showtime. It also has a unique stamp or hologram from the theater itself, such as a JWT's signature. Um, this stamp proves that the ticket is authentic and was not forged. Once you have the ticket, you don't have to go back to the cashier every time you go into the hallway. You just show the ticket. The usher can quickly verify it by checking the stamp. And then the usher doesn't have to call the cashier to confirm it's self-contained. So everything needed to validate your access is right there on the ticket. The beauty is that JWTs let servers validate requests without checking a central store or a database, much like ushers validating tickets without phoning the box office. Next, let's talk a little bit about the ups and downs, the pros and cons of using a JWT. Pros are it is incredibly fast because there is no database lookup. It is stateless. It is scalable for microservices, and it's good for the APIs and mobile apps. The cons are It cannot be revoked unless you build in a revocation system. Misconfiguration can be a catastrophic nightmare and lead to leaks. Refresh token theft is your biggest risk with these, which is why many tutorials tend to stop at the signing of the token. But here we're gonna keep on going. So let's review some best practices with when it comes to JWTs. You want to use short-lived access tokens. Like I'm talking anywhere from 5 to 15-minute access. You want to keep all of your refresh tokens, TTLs, or time to live, something reasonable. Something like 7 days, maybe a month, maybe as most as a month. You want to store refresh tokens securely. You also want to hash refresh tokens inside of the database. Never store raw data. That's like storing a raw password. Rotate these refresh tokens once they get used. You want to be able to detect reuse attacks. So, for example, suspend login attempts after X amount of fails. You want to revoke the full token family when a refresh token gets used. You want to store user agent plus IP information for context and normally for anomaly detection, such as, hey, you haven't logged in to this address before. You also want to use CSRF protection for cookie-based authentications. Now, CSRF is cross-site request forgery. This is an attack where a malicious site tricks a logged in user, the logged in user's browser, into sending unintended requests to a trusted web application using the user's existing authentication. This is why you want to follow best practices whenever you uh, develop code. Next, we're going to have a look at my polar diagram for login flow. So when a user logs in, the authentication service then validates the user's credentials, typically by accessing or querying a database to check that the user exists and to validate their login credentials. A JWT and a refresh token are then issued. We hand back the JWT in a header, and we store the refresh token into a database. So next we're going to have a look at a refresh flow. So once the user signs in and we check to see if a refresh token is needed. If it's not needed, okay, we just give the JWT and hand it. If a refresh token is needed, then we query the database to find a valid token. If none exist, we return with an error message. If one does exist, then we use that refresh token as our secret to then generate a new JWT, and then we revoke or we remove or invalidate the refresh token. And we generate a new refresh token to take over that one. So let's take a look at what this looks like. So here inside of our web security config, I am um, stating at the top that the session management is going to be stateless. I then handle the CSRF, allowing people to go to logout, to the logout section. I then grant full OK or full permissions to go to any of these URLs. So if we're going to the home page, if we're going to an error page, if we are registering, logging in, logging out, or accessing refresh tokens, as well as our resources, are all permitted. Anything that goes to dashboard has to have the role of user. Anything that goes to API, which is an internal API, um, has to also be authenticated. And then anything else that we haven't already explicitly stated is going to be required authorization. So the next section down here, we are making sure to add in our JWT authentication filter before. This is why we're doing this add filter before. We're adding this filter before the username password authentication filter. So before the user puts in their login creds, we're going to check to see if they have a JWT. So next, let's have a look at the JWT filter. So if we open this up, here we can see where we are fetching token. This is where we get the token or extract it from the header. Then we validate it. Then we check to make sure it's not empty. Then we validate the token. Once we have validated the token, we then load the user's details, their claims, the principals, the roles, and authorities. After this is all finished, we then grant the authorized user. Sorry about that. And then we pass them along so that we let the request proceed. And if we pop into our JWT services class, here is how tokens are generated. So using this class with claims, we include using a secret key, configurable expiration times, and then we're signing it using the HS256. So here is where we take track of now, the expiration, which is our time, which comes from up here, which comes from our 15 minutes. So we have a 15-minute token that will expire after 15 and require a refresh token. We then fill up our claims full of the roles that the user has. And this is then where we set the issuer, set the audience, set the subject, set up the issued at, expiration, add the claims, sign it, and then we have our string that we have is what is returned. So looking into the token hashing service next, this is where we take in a raw refresh token, which is never saved, and we pepper it a little bit. Why do we hash our refresh tokens? So hashing the refresh tokens is the new modern standard because it prevents attackers or even, you know, insiders from misusing stolen database entries, making refresh tokens function more like passwords. So refresh tokens are long lived. These are the things that are anywhere from 7 days to a month. So refresh tokens are long lived. Unlike your access tokens, which expire pretty quickly, refresh tokens can often live for days or weeks or up to a month. So if they are stored in plain text, anybody with database access, whether it be legitimate or illegitimate, like malicious attempts, could then imposter users or impersonate them. So hashing makes things a little more opaque. By storing only a hash, um, the server can verify a presented token by simply hashing that token and then comparing it. So even if the database did get leaked, attackers cannot directly use the hashed values. So let's take a look at how we issue a refresh token. So we start out by taking the right now, and then we take in however many days our refresh token lives for. We then have this raw version, and then we have this hashed version after we've hashed it. Then we simply create a new refresh token. We set it up so that the ID is a unique ID. We add the email to the as the user. We set the token hash. So this is the actual refresh token. We assign when it was issued, when it expires, and the user agent, as well as the IP address. We then save that to a database, and we return the issued result. Next, beneath that, we want to validate the activity of the raw token. So here's where we then hash the raw token. We check to see if we've found it inside of our database. If we didn't, we return an empty optional. If we did, we check to see if it has expired. If it did expire, we return an empty optional. Otherwise, we return the active token. When it comes time to rotate said tokens, we come down here, we provide the raw token, user agent, and IP so that we can hash the token. And then again, we're going to find it to see if we have it. We're just going to go ahead and get it. If we don't, we're going to return an invalid. We're going to then grab it, check the current date, and we're going to see if the revoked at. So if the revoked at time is not null, then we want to do some detection, which I haven't fully written yet, but we want to then do some detection for login uses. From there, we want to see if we've revoked the family, and if we have, then that's when we then want to go ahead and revoke all of the related tokens. And then we're going to return that it was reused. Otherwise, we are going to continue on to check to see if it's expired. If it is, we'll return that it was expired. If not, we're going to um, finish filling out the rotated token, save it to a database, and then return that we've now rotated our ticket, or sorry, rotated our token. So that is how I've implemented it. So let's give a little recap. We want to be favoring short-lived access tokens. We want to use long-lived refresh tokens, and we Can't forget to hash them. I can't stress that enough. We want rotation. So you want to be able to rotate those tokens, and you want to have family recovation. I can't even say that word or pronounce it, but you want to be able to revoke the tokens from the whole family. So that's how I use Spring Security to lock down my website. If you've made it this far, thank you for watching. I hope you learned something today. I learned a lot along the way. If this sheds some light on JWTs for you, leave a comment telling me what it was that tripped you up the most, and I'll see what I can do to answer those tips. You can join our Discord if you want to get involved or have any questions or want to just talk tech, talk shop. Link is in the description. The Midnight Technician is built for you to explore. It is not just a code base, it is a learning platform. So, if you've enjoyed this video, hit that subscribe button and join me on the journey as we continue to build this project together. If you like the project, make sure to share it with a friend that might find it useful or may be willing to help reach other developers. So, as always, keep your curiosity open, your skills sharp, and keep that coffee cup full. I'll catch you in the next one.